So, hello everyone. We're here to tell you about the adventure we've had over the last year building the site, the infrastructure that you've been using, show you how we built it, the challenges we faced, and how you used it. And since everything started from the site design, I'll start by introducing Russ from the admin team, who is responsible for it.
Yeah, so for the first time in an infrastructure review, I'm actually going to talk about something, and mostly about the bits of over-engineered technology that we use to actually design and plan the festival. Oh, there we go. So we signed the contract for this site almost a year ago, actually, I think. It seems like a really long time ago, and we've had a couple of site visits up here where we've come up and camped for a weekend and gone around and sort of worked out where everything might go. And it's exceedingly difficult with this site because there's a lot of everything has to be on something approximately flat, but that's not many places around here. And it also doesn't have to, very importantly, the tents don't have to go on top of water mains, as we found out in 2016, and various other more practical things like where do the roads go, how can we use the roads so that we don't have to rent in so much trackway and so on. So this is one of our planning sheets that we did back in March or something, where we kind of drew in what we thought we had to do. And then this is our CAD plan with all the layers turned on. So it has the underground services and the power and the network and the lighting and ducts and pipes and all sorts, trees, stumps. And that's how the web map is generated. It's generated directly from that CAD plan. We have this increasingly sophisticated pipeline which we can use to turn a CAD plan, which is good for precisely planning where things go and making sure that the tent is not too close to the track or things like that. And then that turns it into a web map, which I completely rewrote this year to be vector and fancy. And it mostly works, except in some people's weird browsers. But it's not my fault. Oh yeah, there's a diagram of that, which used to be much more complicated, but this is the kind of simplified new diagram, which isn't quite as annoying. And yes, the docs are out of date, sorry, as always. But we also got signs this year. I'm not sure why I'm talking about these, but it's quite exciting, actually. The council were like, you should have some signs to tell people to slow down. So I called the AA and I was like, do some signs for us. And they were like, sure. And it was the easiest supplier I had to deal with, and they didn't even charge us very much. So I hope people found them helpful. We didn't really need, I don't think we needed all of them, but they seemed to work pretty well. And then the day before we came on site, somebody delivered the bins, which was kind of them, but they put them where we were going to put our initial logistics area. So we then had to move about, 10 tons worth of bins, probably not 10 tons. And then they came around a bit later with a bin washing machine, which was exciting. So it was exciting. But now So now I'm going to talk a bit about our power infrastructure, which I've been perhaps a little bit too much involved in designing this time because I decided to completely rewrite the software we used to do it. There's a common theme with EMF, this doesn't work, this doesn't quite work the way we need it to, let's write a completely new system. So we have this computer-aided power design system, which takes our main plan, which I showed you before, and converts it works out if the plan is valid and the right things are plugged into the right people, the right panels and so on, the right people, yeah. And then it spits out some lovely graphs. So this is one third of our power this year. I can barely see that, so I don't know how well it's coming out on the expensive projector. So that shows every single piece of distribution equipment and the links between them and how much voltage drop and prospective fault current and all those things that I've been nerdy about for the last 6 months. So we've been trying to because the EMF power system is entirely done by EMF rather than an external company, we have to make sure that we do all the testing and validation of it. So this is part of that, and it tells you whether the cabling is not big enough or various other things. and flags it all out in this huge diagram. And then, of course, no plan survives contact with the real world. So we did put our power order in quite late. Our supplier, Templon, are fantastic. They're actually one of my favorite suppliers, and I do have a list of my favorite suppliers. They were like, oh yeah, we're going to have to substitute a few things and move these things around. We don't quite have enough of these, and we don't quite have enough of those, and then we ended up with this mess. So we had, oh, that's clipped. It should say 119 power distribution boards of more than 16 amp. More than 5,200 meters of power cable, 3 generators, 2 of which were 300 kVA and 1 was 200 kVA, so that's 800 kVA, or about 800 watts of power capacity, of which we had 130 kilowatts total peak loads. Like, we didn't need those big generators, and in fact we didn't order them. They were like, sorry, you'll just have to have these vast 300 kVA generators. Somebody went round just now and counted all of the people plugged in, and apparently there's more than 400. I didn't verify that number. So this is the main supply of one of the generators. That's the one up there, and we have these juicy 400 amp cables going away from those. And that's a container full of all the power distribution that we have, several tons of it. And we did a bit of aerial power rigging with some very heavy cable, which was, it worked. It was a little bit wobbly. It didn't fall down, which is good. And yeah, there's a small sample of the 400 connections plugged in and a fire extinguisher, because safety first. So in EMF 2016, we had a bit of a problem that we didn't tell you about. Over the weekend, we realized that we were getting really close to the wire with fuel. And so we had to get Benny under this telehandler and get him to unscrew the fuel drain plug and siphon the fuel out of this telehandler into the generator. So this time we didn't want to do that, so we got some bigger fuel tanks, much bigger fuel tanks, and they all arrived and they dropped them off, and then they were like, oh yeah, we've just gone and picked these up from another site, and they're all empty. So this was last Tuesday. They just turned up with all this equipment, and they're like, oh, the generators are empty. So we had to find somewhere to buy 6,000 liters of diesel, which is quite a lot of diesel. It's about $5,000 worth, and they couldn't come until Friday, actually. They came, and so we had to get Templon to chuck us over another fuel tank to kind of make do. That's what an empty fuel tank looks like, in case you hadn't seen one before. That's what an empty fuel tank generator internal fuel tank looks like on the left. And yeah, putting the lighting in was a bit of a challenge this time. It turns out this particular site is very, very hard. And usually we put these bits of metal in called put logs, which hold the festoon poles up. We had way more festoon that we could have put up, but we didn't, because we couldn't get these things into the ground, and we kept bending them, or it just didn't work, or the telehandler would tip over or something like that. But we got, I don't know if 1 kilometer is the amount of installed lighting, but for the first time we used LEDs rather than incandescent bulbs, which saves a lot of power, and it's also lets you wire them into longer strings, so that's why they all look cool white. We did a bit of site lighting finally, thankfully. Last year, last EMF, I volunteered myself to try and do some of this, but I was way too busy, and we got a load of lights out, and then some ArtNet problem happened and never worked. But now we have an actual site lighting team, and they've been doing some pretty stuff, and next time it will be even more pretty. That's a guarantee. They're using these off-the-shelf Ethernet to ArtNet to DMX nodes, and a load of DMX cable, and a laptop. This presentation's been reordered since I last looked at it, which was 8 minutes ago or something. This somehow got found somewhere. I'm not sure what was going on there. Did they try and stick it in the socket? It was in the socket, I'm informed. So don't do that. Like, they're not compatible. And I'm going to leave you with David.
Yes, so hello again. I'm David C. from the NOC team, and I'm going to talk to you first about the uplink. Some of you who've been to EMF before will recall the first few events we were running wireless point-to-point links, and every time we ran one we swore we're not going to do that again. Unfortunately, this time it wasn't even an option, because you may have noticed that there are many hills around here which would make it basically impossible, even if we had somewhere useful to go to, which we didn't because we're quite far out here. So planning for this actually began around about the time that we first came to visit the site and investigate in August last year. And we quickly realized that we're going to have to get a circuit from a commercial provider somewhere out of the site. But what we wanted to do was make it really easy for the supplier to put it in. So we built a cabinet right by the road, ran ducting for them right to the road, so all they'd have to do was, in theory, was connect up their duct to our duct, pull some fiber through with the rope that we provided. So we were here in January digging in some very hard ground, getting trenching in for the ducts to the road, power to the cabinet, and some sheep were in the field. This field was not actually a camping field at that time of year, so by popular request, someone keeps tweeting EMF webcam asking for sheep. Here are some sheep. And this is in fact a deer park. We saw deer in the adjacent field as well. We were careful not to interfere with them. So this is what we ended up with. This is how we left it, and here's how we returned to it, covered in weeds later, well, a couple of weeks ago, in good condition. In the meantime, the provider had come, hooked up the duct, and excuse me, here's an example of just outside that cabinet, in fact. You can see branching off to the left are two ducts for circuit providers. One we used, one is in reserve for future use. The duct going off to the right, which was hastily added last week, in fact, with some PVC bonding cement and ghetto homemade swept tees, actually comes all the way up here to site, because what we discovered using the documentation, fairly illegible documentation provided by the site, but actually walking through and actually looking at manholes and seeing where things went, is that we would, in theory, be able to pull fiber all the way up to the site. Backup plan, same as usual, throw fiber in a hedge, run it down the ditch, throw it away afterwards. So here we are. This is about 1.2 kilometers of fiber. We rodded last Sunday. Seems like a month ago. The manholes are every 100 to 150 meters, sometimes a bit shorter, but for each one we push this yellow, very stiff rod through, pull back a rope, and then pull the rope back through again, all the way. This on the right here is the main fiber, 8 cores, just in case something goes wrong. And apparently we energized Team Synergy to assemble an enterprise-grade fiber spool unspooling solution. There we go. And yes, this was splicing in the back of a van down by the main gate to hook that in. Here is our network operations center, which we got running fairly early. It was the staging point and the distribution point for taking the switches, sending them around the field with the access points to be installed in the Darton Clow. And as for our data center, well, we've tried a few things over the year. In 2012, we had a rented scout tent with a full 19-inch rack, which worked pretty well, except it was hard to cool and kept getting bits of field in all the equipment. 2014, we had a refrigerated shipping container, a reefer, which was great. It was so cold. The problem was it was too cold. You couldn't set the set point high enough to stop it constantly chilling. And because the door was opening frequently, people going in and out, it produced a load of condensation that was blown over all the switches and servers, which had to be covered in tarp. So cold, but side effects. 2016, we went for what the bar used, which is a cool room, basically. We didn't realize at the time that the inbuilt chiller unit was mostly designed for keeping already cold things cold, so food, drinks, rather than actually cooling enormous amounts of thermal output from switches and servers. So we did actually have to buy aircon at the last minute. But other than that, it worked really well. So that's what we use this year. This is the assembly of the cool room, the cloud services data center, the former location of the inadequate cooling unit has been replaced by a fiber and copper entry port. And this is what it looks like inside. Heavy stuff on the bottom, UPSs, very heavy, and the servers. And then from left to right, we have the wireless LAN controllers and some of the Vox, the video team's servers. In the middle, we have, at the bottom, we have the core switch where every fiber around site is plugged in. But we'll get to that in a moment. And on the right are those fibers. Yes, you may have noticed that there is no flat on this field, so bodges had to be involved at certain points to stop the air conditioning tipping over onto the servers. Now, the NOC DC was actually positioned where it is because we wanted to use the manhole that runs all the way down, or the duct from the manhole that runs all the way down to the front gate. So unlike previous years, we only had one power feed. In previous years, we've had feeds from 2 different generators, but this time we didn't. But everything worked fine. We had a resilient pair of UPSs and an automatic transfer switch for the servers that couldn't take dual power supplies, and we had no outages at all. And I'll hand over to Niels.
Thank you. I'm Niels, and I'll talk a bit about actual stuff out in the field. This diagram comes from the same CAD system as was used for power distribution. Lots of shared development there. Purple lines are the fiber that goes across the field, so from central places to all the data flows. The circles are roughly 50-meter diameter circles around each data flow, being 25 meters, kind of a rule of thumb. You can't really expect people to bring longer cables than that. So data flows spaced out on the field, so that the circles just almost overlap. And if you pay attention to where the purple lines go here, you will have noticed that these are all little islands. And one of the big features of this field is that there's infrastructure between several places that we could use to transport data where we didn't have to cross roads. Because road crossings are really annoying to do. There's lots of traffic always and vans and stuff. So you can't put fibers there, you have to work with ramps, which are expensive and heavy. And this way, with lots of cores from between 3 places on the field, saves us a lot of hassle in deploying a working infrastructure here. So this is the duct plan. There were 3 manholes, and we had up to 12 cores between different places. Basically, these little LED signs are splice boxes with a watertight cover over them, and at each side we would break out a couple fibers, and the rest would go on. So from the core, we had a star network. From the core, we could patch everything all the way through to the end of the field without having to have any active equipment all over the place. Oh. Where are we? Right. So this is how the network plan looked. This is the logical diagram. As you can see, everything is connected to the core switch, to the core router, eSNOR. I'm assuming a non-native English speaker wrote that down after hearing a British person say it. And the couple places where we didn't want to run fiber because there were really short distances, and we had 10 meters of copper cable, and that is the bottom layer you see in this diagram. Yeah, it's sideways, but landscape. And this is the physical diagram, which you can see is different. And these are not switches, but these are the datenclows all over the field. So, for example, you can go from the left to the right in this diagram and follow the cable from one datencloud to another all across the field with no active equipment in between except where it says copper. So again, this is coming from a single source of truth, which is really helpful when troubleshooting problems and making sure that everybody knows what actually is the network design that is being rolled out, what VLANs need to be where, and just finding out what is where. This is one of those splice boxes that we had a couple of through the field. On the right side, you see the black multi-core fibers, outdoor fibers that run underneath the ground come in. Then they're spliced onto pigtails in the white bit with the laser warning. And these end up on pigtails that are then put into connectors on the left. And all those cables go to the switches. The connector on the right is the uplink, connectors on the left all go to the field. There's 2 cables coming into this, and we had 2 more of these out in the field. And when the event is over, we roll up all the cabling inside and put the top over it again and put it back in the trench. And then, I don't know, maybe in 2 years, we can come back and we don't have to do all this splice work that Dave showed all the photos from. The datenclow, for people for who this was the first EMF. Originally, I think invented by the Germans, copying a concept from the Dutch. We lock them because we don't want people to mistake them for what they actually are, normally. This, you can see there's power going into it, there's fire extinguisher next to it because it's a nice central place where you can have them. The little wood tower on top has an access point in a container box upside down. And on top of that is an ohm light, and you will have seen those display fire. They're very good, very useful, because if you walk around the field, you can immediately know, oh, there's the nearest network access point. And you can run your cables there. And should it lose internet connection, then the fire flame animation will stop, and you immediately know, oh, there's an outage there that will need attention. This is from the inside. Cables coming in on the bottom, one going out to the access point and to the ohm light. There's a switch in there, there's the power distribution unit there. And this one, I think I took this picture on like Friday afternoon, so not many people around who had plugged into this one yet. I don't think we ever ran into a situation at this event where we needed to add a second switch because we had needed more than 48 ports. So a couple of these ports are of course reserved for our own stuff, like the ohm light needs a connection, the DECT phones need a connection, GSM, base stations, and the access points. We had some power over Ethernet switches. Most of the access points were connected via PoE injectors. But this was a PoE switch, I think. Right, stuff that went wrong. One of the challenges is you start out and you arrive on site and you build out this little temporary network just because, we need to be online. And the orga is breathing down your neck going, can we check our email yet and everything? We need this for production. So you build something temporary, and then as the event starts, you need to move from the temporary setup to the final setup. We had one little device in one of those cabinets that we had built up the road to serve as a media converter, and then we had to take it out. And whenever we took it out, the normal equipment couldn't take over because the traffic just wasn't accepted at the remote end. So this was a link that had 3 different suppliers involved, so we had to contact them all, have them all debug their little part of it, and then eventually it turned out there was probably some display bug in the switch on the remote end in London that was dropping all the traffic without actually indicating that it was all the traffic. So this is why, in practice, for you to notice, IPv6 took until, I think, the afternoon of day 1 before IPv6 would work, because we needed the new final equipment there. Something else, We worked for like 2 hours on getting the switch online via copper uplink, and we changed everything, and like the cabling, re-crimped it, and then finally we're like, okay, let's not use the copper SFPs. This particular switch has 10 gig ports, and we put 1 gig pluggables in there, and normally that works. These are multi-rate slots. But after we took them out, you can see that the lights, the green lights on the bottom row that are lit up, are the link lights. So this switch currently thinks that these ports have a working link, which is obviously not the case, since the pluggables are lying on top of it. So yeah, 2 hours of re-crimping cables. Drawing in graphs is a hobby that certain people took up, where if you have a public graph, then it goes up and down as the day progresses. But if you have significantly more capacity available than you have usage, and you have a place where you can send a lot of traffic from, you can create a nice spike, and it goes up, and then you stop sending traffic, it goes down. And it's all fine and dandy until you don't have much capacity available, and you DDoS the campsite that way, which is what happened here. We only had a gigabit. It was enough for everything we did here, for all the traffic that the people did, for all the streams to go out and all that, but this didn't really have much capacity to catch incoming DDoS attacks. So the NOC had to spend time and effort contacting our upstreams, identifying the source destination, and we ended up having to take the public dashboard offline from being able to be accessed from the world, because that was the target of the DDoS attack. And the source was somewhere in a group in Germany who deal with open Wi-Fi network development, so to speak. So yeah, please don't do that. It is annoying, and it inconveniences everybody on the site and creates work for a NOC. And finally, this wiring that you guys have here. Luckily, somebody brought stickers to notify us of the problem, which were widely deployed, and I think these were good safety measures. This isn't my first visit to the UK, and I know that you guys like warning signs and safety signage and everything. So the European Mainland Federation was glad to help out. Of course, Europe being Europe, we also propose a solution that we will help you implement 2 years from now. Thank you very much.
Yes, this is the problem with having a presentation that you need many teams to work on simultaneously, and opening it up, someone will put in a troll slide. Thank you, Will. Wi-Fi. So I'll hand over now to AK, who's going to talk about the Wi-Fi distribution through the camp and give you some stats.
So, Wi-Fi. Well, it's about putting up lots of access points. I guess this slide didn't come in too well. Okay. Shit. Okay. So some of the photos are not on here, that are supposed to be on here. But yeah, we put up a lot of access points, around 70 of them. On the left, you see a few of them when they're being staged when we were back in the Netherlands. On the left, you see an access point mounted to a fence, and on the right, you see the access points we have mounted on all the datum close. So that's actually an indoor access point that's mounted into a plastic box that's used for waterproofing it. So that's a fairly cheap solution to use a cheaper indoor access point and making it waterproof. And on the top here, you see also the GSM antenna and one of the ArtNet ohm lights. And there was supposed to be another photo on the right, but we can't see that. Some statistics about the Wi-Fi deployment here. So we had 72 access points deployed, all 8211AC Aruba access points. 2,800 concurrent stations that were concurrently connected to the network. And in the course of these 4 days, we've seen around almost 6,000 unique devices on the Wi-Fi network. And actually, most of the devices connected to the network were actually on Wi-Fi, about 94% of them. So only 6% of those devices were actually connected to the wired network. So yeah. Yeah, we also had a number of SSIDs. Well, most of them were encrypted and some of them were unencrypted, but almost 70% of you guys used the encrypted network, so that's good. And 80% of the stations were on 5 gig. I think the badges, they cannot do 5 gigahertz, so that maybe they are taking down the percentage of stations on 5 gigahertz. And of course, 5 gigahertz has way more capacity than 2.4 gigahertz. We're also, here in the UK, the Ofcom opened up a little bit more spectrum, so they added 5 more 5 gigahertz channels. So we were able to use 24 5 gig channels, opposed to 4 20 megahertz channels on 2.4. So there's way more spectrum to play around with on 5 gig, so please use 5 gigahertz. And yeah, maybe 2.4 can maybe go away at some point, but yeah, some more statistics in this slide. You guys were able to actually use a random username password on the encrypted Wi-Fi, but apparently not, well, almost none of you actually tried to do this. So it's EMF and Anonymous and some Ethereum realms that are in this top 10. So not much exciting things going on. On the different operating systems we've seen on the network, Linux is on number 1, so that's good. So, and for some reason there's Windows 98 there. That cannot be right. Right. We also collect a lot of more data about the Wi-Fi network, like we can look at how many clients that are associated to the different access points spread across the site. So one thing we can do is we can look at how many clients are in a certain room. So we can use this data to see which presentations are popular. So we can see that apparently the most popular talks were banned from encrypting and the making of the tilde MK4. And also, yeah, hackers was very popular yesterday, so that's good. And Sidebar was also crowded yesterday. Oh, very nice. And Milliways was also popular yesterday, so something with WikiLeaks, I guess. So that was it for Wi-Fi. We have some other statistics. Yeah, so we have this 1 gig uplink, and we, yeah, it was saturated. So because, thanks for that. Yeah, so next year we have to have more bandwidth. So, or next 2 years we got to go for 10 gig or something. Yes. Yeah, this is the. So we see a couple of peaks there, but that might have not been genuine traffic. But yeah, we'll get more, I guess, next year. Yeah, so temperatures. Yeah, it was last night. It was pretty okay during the night, but the night before that, it was very, very, very cold. So you can actually see about a, I think it's a 20-degree difference during the day and during the night. So if you're looking at the temperatures of all the switches we have on site, so I think, yeah, it's probably 20 degrees difference between day and night. So that was pretty cold. I think that's it for statistics. So we're going to move on to video. Yeah. Okay.
Yes, so some of you may have noticed we haven't done our usual thing of having very strange graphs like radiation level or Club Mate stock in the bar. This is mainly due to everyone being absolutely knackered by the time all the logistical issues were sorted out. But now I will pass over to a team far more professional and streamlined than our own, the CCC Video Operations Center, and pass you over to Votti.
So, hi everybody, I'm Votti from the CCC ROC, which is the video team of the CCC from Germany. Let's start with a few statistics of our live streams. So, we had around 100 viewers at the peaks, up to 120. Most of the people were watching MPEG-Dash live streams, which is like an adaptive live stream technology. And Apple devices mostly use HLS, and some legacy devices watch the IceCast streams. Those are statistics from our ticket tracker. So overall, we recorded 117 events. 26 events were not recorded. Those were either speakers that didn't want to be recorded, or music and movie events that aren't being recorded. And overall, that's almost 62 hours of video being recorded by us. And most of the stuff is already online, and you can watch it. So we also faced some challenges at EMF. First, those tents arrived late, and we had to do everything at Friday morning, and it was really stressful. But we got it. So, and during the build-up at stage B, there were some power outages, which also didn't help. For the first time at this event, we normally render our videos with an intro at the beginning, which is like a small video which says who's the speaker and what name the talk has. The guys from EMF wanted it to be like a transparent lower third thing, and we had to build it in our pipeline. But at the end it worked out, and so now every video starts with a lower third which has transparency and overlays over the video. One talk actually had an emoji in its title, which was a little bit challenging. But everything worked except the automatic intro generation, so I had to fix this manually. But apart from that, it's already up on YouTube and on our own platform, and everything worked. And actually, on this stage, one HDMI splitter was bricked by a Tesla coil, and so on this stage we have some problems with like the video on the projector, but I think it's working now. So, thanks for the appreciation. We also really like this big Lucky Cat. And you can find all the recordings up to now, and some are missing at media.ccc.de and on YouTube. Thank you.
So many of you will already know, for the first time at EMF, we have a DECT network that has been very well received. This was put together by the event phone team, who are testing out their new system here. Unfortunately, they have had to leave early. They've kindly left their equipment in our care. But Sam will be talking on their behalf, and he's also going to talk about the GSM network that he built.
Thank you. So yes, my name's Sam. I've been involved in building the phone network, mostly the GSM, but the kind of, as we'll show you, we had like a common core. So I worked really closely with Thomas and the DECT, the event phone guys with the DECT stuff. This is Thomas's presentation that I've seen once, so this is kind of risky. I don't know where you might have slipped in there. So first thing really, we, as you see, one of the big things that Event Phone put in this year was self-service for DECT registration. Those of you who've been to Congress before, you know, like signing up, waiting to get your DECT phone online had to be kind of a fairly manual process, one registration at a time. So they put a lot of work into building a service the way you could just register. So the DECT antennas were effectively always in registration mode, so you could just pick up your phone and say, register to network. It was a default PIN. That kind of gave you a temporary allocation on the network with a really long number that wouldn't route anywhere, and then you could register your number in Guru and just dial the activation code, which actually then like re-provisioned your phone. So I think that was quite a lot of work. I think it's worked really well for them. I think most people found that was fairly good. It also meant that number registration Guru system we built was not just for DECT, but actually we extended it to cope with the same for GSM and, well, for SIP, so you could just SIP register a phone. So I've been using my iPhone with just an application on it all weekend. I haven't actually even got my DECT phone out of the box, but you actually had like 3 different ways to access the same phone system, and you could have a number on any of them, and you can have call groups and that kind of thing. So yeah, that's worked really well. The kind of principles we could apply then from DECT to GSM. So kind of unified experience across the networks. Really, we have one phone system, different access channels. Things that they've learned for EMF. The capture, those of you that signed up very early on in Guru, I think found the capture significantly challenging. Either that or everybody was a robot. But so there was a little bit of a, yeah, we'll turn down the aggressiveness on the capture. Displaying SIP details, it's mostly been kind of UX type things in any web application. They added call groups as well. I don't know if anybody found that, but if you had you could get a number that would ring multiple extensions. So if you wanted like a number for your village that would ring 6 people's DECT and GSM phones in the village, you could register that as well. That was kind of a late addition. So this is kind of what the IP architecture looks like. So we ran, in terms of hardware, all these servers were running on VMs that David kindly provided for us. So we had these built up a little bit ahead of time and then moved to site. So there was a Yate, which is yet another telephony engine you might be familiar with. It's a SIP control platform. So there's a number of Yate instances, which was kind of handling each segment of the network for VoIP. So the DECT stuff gets converted into SIP as well, as does the GSM, which I'll show you over there. So we had a kind of a VoIP core server. Then we had the DECT antennas you'll see on that cloud. So they were running as a private VLAN across the site. So all the DECT antennas were plugged into a specific switch port on the VLAN. And then the GSM BTSs over on the right there. Similar principle to the DECT antennas. We actually, so the hardware, for those of you who haven't seen some of the other presentations, the GSM base station is a Raspberry Pi and an SDR radio. So we have a Raspberry Pi, we have a Raspbian OS on there. We could just run an OpenVPN. So the BTS itself just plugs in, fires up an OpenVPN tunnel back into our VoIP core, and then runs the GSM over there. What was really nice was it meant that actually I've had one of these base stations plugged in at home on my DSL when I've been doing testing via the same VPN. So we can actually deploy a base station anywhere in theory with that technology. And we didn't have to kind of rely on a custom VLAN for that. Just some management stuff over on the outside, and then you'll see the little logo over there. So quick plug for my employer, Nexmo, who kindly gave us a bunch of credit to make so all the external calls, traffic out to the PSTN was routed out through them. We had the 2 little GSM servers at the top there. The GSM core is the Osmocom core network in a box stack. So that was providing our, for those of you who know the GSM acronyms, the MSC, the BSC, and the HLR, and the SMSC were all running in one on that box. That just has a SIP interconnect, so that came out over SIP that way. And then the GSM services was just an asterisk box for doing a few little hacks and tweaks, and we put a few little services on there and test numbers, and generally it just gave me a box to do some manipulation. We also routed the outbound traffic to Nexmo through that, and the inbound. For those of you that found the inbound, there was a UK number you could dial. It would just give you dial tone, so from your regular mobile. And then you could dial anything as if you were on site. So you could dial people from off-site, could call 07520 660 900, and you'll just get dial tone. So this was what was on the network. We don't know exactly how many GSM devices attached to the network. We know we had 1,900 GSM-enabled devices at some point, but we didn't have great stats on the traffic on there. That could have been literally just one location update or phones attempting to location update, so people's phones that may have tried to register and been barred or something like that. 277 DECT phones, 70 SIP extensions, and 33 people signed up for a personal SIP number, personal GSM number. So with the SIMs we gave you in the badges, we used a similar thing to DECT, but actually you'll find they all had a number, which was that 1234 number. You keep that number and just use it, which is what people that got their GSM working did. But equally, you could have reassigned it yourself to a personal number as well. So the active calls going out to the real world. We had this little problem, as you can see here on, I think it was, started at just after 4 a.m. on Friday morning, is that? Through till sometime 12 o'clock. Basically, somebody hooked up one of their SIP extensions to their SIP server rather than to a phone. and their SIP server wasn't a particularly well protected server. So somebody out on the internet, anybody that's ever put a SIP server on the internet will know it takes about 20 minutes before somebody starts trying to poke you with call attempts. They poked their server, they found, oh look, it can make outbound calls via our server, and that burnt through about €1,000 of credit calling Serbia. So I had to have an awkward conversation with my boss then on Saturday morning going, that €1,000 of credit you gave me for EMF, I've kind of lost it. Can I have some more, please? But fortunately, he did. I just checked the balance, and actually, since we locked that connection down, and we put a few limits, we blocked SIP for outbound calls, but from DECT and GSM, we've actually only used €60 of credit of legitimate calls, so outbound and inbound. So yeah, that was definitely some fraud there. We did only allow UK, Europe, and US prefixes anyway, which should have generally blocked out the obvious fraud destinations. I kind of missed maybe Serbia. That will go in my banned list for next one. This is one quite interesting little thing from the DECT network. So the DECT base stations all need to synchronize with each other because it's a time division multiple access system. So all the base stations need to be on a synchronized clock. We don't have this on GSM, which is why we don't have handover right now. What the DECT system can do is they synchronize over RF links between them. So all these lines are, you'll see the spots are where all the DECT antennas are. So you can even see the one right down at the gate. So there's one in the DK at the gate there. And they actually discover each other. And even a red link is a low quality, red, yellow, green quality links. But these would all keep them in synchronization. So they're synchronizing over the DECT RF band with their channels. Couple of plugs. The challenge for Event Phone is they're trying to get more followers on Twitter and YouTube, so they're clearly trying to break into social media. Very quickly, the GSM stuff. Challenges we had, the time frame, getting it all built, really, I was being pushed. We were right up against it, and we were reliant on so many other bits of infrastructure, so we got pushed out there. Deploying the BTSs in the real world. All this stuff worked really well in the lab when Lime SDR built the boxes, and I've had stuff running on my desk at home for weeks. Turns out when you start sticking it on a wooden pole in a field, some of the environmental things. So Thursday night, I think it was furiously spent soldering additional 5-volt power lines, Raspberry Pis, USB power. Anybody that's been there will know that. And yeah, manpower, womanpower. I really kind of ended up doing most of the GSM stuff myself with a bit of help from Thomas. A big shout to Yaga, if she's here, who helped putting up the base stations on Thursday, and then went around and took them all down when I said, actually, what I thought was a software problem is a hardware problem, and I need to solder some wires into them, so could you go and get them all down again and bring them back, please? And then put them all back up again. So yeah, she did an excellent work. So we can see where the GSM was busy. Surprise, surprise, not many people are making GSM calls at 4 in the morning, but there's a traffic distribution graph there. Thank you, David.
So at EMF, we're always trying to keep the ticket price as low as possible in order to encourage and make it available to as many people as possible. And we have to always balance that versus things that we actually need, or people expect, like an internet connection. Paying for an internet connection and equipment and setup about the size of a small ISP that is used for a weekend and then thrown away for 2 years isn't really something we can afford, nor would we actually want to. So we rely on the enormous generosity of a whole slew of sponsors to lend us equipment, services, and other favors. I'd like to give a particular shout out this year to Sky for Business, without whom we'd have no uplink at all. Our uplink goes via a circuit to a nearby town where they have a point of presence, and they take it to London for us. We had very few options there, and they were awesome. Absolutely, many thanks to them. And I'd also like to thank the others, who I'm just going to read out very quickly because we're out of time. Event Infra, Flex Optics, Sargasso Networks, Lonap, Comtech, Clarinet, Babel, and Arista. So many thanks to them. I also want to thank the volunteers who pop by from time to time offering to run around the Datenklau to plug people in. We need your help again to unplug them. And beginning tomorrow at 9 a.m., we begin teardown. That's bringing back all the cables, all the fibers, all the switches. If you're able to help out, please come by at 9 at the knock tent. I think that's it. These slides will be on our GitHub, and here's our Twitter.